Physicists have debated the role of consciousness in quantum mechanics for more than 100 years. Some podcast episodes will soon reach that length, but I have a dentist appointment in 2 hours, so we'll have to wrap it up a little more quickly. Why did some physicists like von Neumann and Wigner think that consciousness is necessary to make sense of quantum mechanics, and can consciousness influence the outcome of a quantum experiment? That's what we'll talk about today. In quantum mechanics, everything is described by a wave function. There's, for example, a wave function for a particle going left and one for a particle going right, which sounds about as exciting as you expect physics to be. But the weird bit is that there's also a wave function for a particle that goes both left and right. This is called a superposition. According to the standard interpretation of quantum mechanics, such a superposition means that the particle is indeed neither left nor right, but both, until you make a measurement. The moment you measure the particle, you know whether it went left or right, and the wave function collapses to one that fits your observation. Albert Einstein didn't like this at all. Yes, that guy again. Einstein said, "This collapse happens faster than light. That's a spooky action at a distance, so it has to be wrong." But Bohr said, "There's nothing wrong with that, because the wave function isn't real. It just describes what we know, and you can update knowledge faster than the speed of light." John Bell used the following example. When the Queen dies in London, the Prince of Wales becomes instantaneously king, no matter where he is. So why wasn't the speed of light limit broken when the Queen died? Because we can update our knowledge about what happened elsewhere without causing any event elsewhere. And this is how Bohr thought about the collapse of the wave function. You can update it instantaneously because it just describes what we know. Einstein wasn't convinced, but Bohr won the argument. So if you believe Bohr, then the wave function has something to do with knowing. But who or what knows? Well, the observer does. By this logic, the update of the wave function becomes linked to the thing that can know something, which is the human brain. Bohr didn't actually explain what this all means. He was quite content with being incomprehensible, and a lot of physicists have since followed his example. But Eugene Wigner was bothered. He thought the idea that the wave function describes knowledge has a big problem. To illustrate this, he came up with what is now called the Wigner's friend experiment. He said, suppose you have created a particle in a superposition of left and right, and you measure it. But you're inside a laboratory and have a friend waiting outside in front of the closed door, because that's how physicists treat their friends. Your friend doesn't know the outcome of the measurement until you open the door and tell her what you measured. Wigner said that for her, you are in a superposition of having measured the particle left and right until she collapses your wave function. He then argued that it would be absurd if consciousness was in a superposition, and since no one knew just what caused the wave function to collapse, he postulated that it was consciousness. Most physicists think today that a measurement is an interaction with some apparatus. It has nothing to do with whether you or someone else looks at the result or whether you tell someone about it. But in the early days of quantum mechanics, it was unclear what the mathematics means. A similar interpretation of quantum mechanics as Wigner's had been put forward earlier by John von Neumann. Despite the German-sounding name, von Neumann was Hungarian, like Eugene Wigner. Both later emigrated to the United States. Von Neumann's argument was that a particle in a superposition can cause superpositions of the things it interacts with. This leads to superpositions of the entire measurement apparatus and everything that follows from that. Say you use the measurement outcome to decide whether to blow up a bomb or not. Then you get a superposition of a bomb that's blown up and one that didn't. And that leads to a superposition of a world in which you died and one in which you didn't, and a superposition of worlds in which you go on to win the Nobel Prize and one in which you didn't, and so on. Von Neumann said that this chain of events needs to be cut somehow, and since everything in physics seemed to keep the superpositions alive, he thought the collapse had to be caused by something extra-physical or psychophysical. It had to be the conscious perception of an observer. The observer either sees a bomb explode or not. That's the end of that chain of superpositions, and maybe also the end of the observer. This idea of Wigner and von Neumann that consciousness causes the collapse of the wave function is an interpretation of quantum mechanics rather than a new theory, because mathematically it doesn't make any difference. That's because the only observations we can make any statements about are those which were eventually registered in our brain. Though you might argue that really there's only one brain, which is your own, and everything else is your imagination, in which case, thanks for imagining me. The Wigner and von Neumann interpretation has problems because all interpretations of quantum mechanics have problems. Reinterpreting maths just pushes problems around like bumps under the carpet. In the Wigner-von Neumann interpretation, the problems manifest themselves as conscious observers who have inconsistent knowledge about reality. If you take this seriously, it'd imply that reality itself depends on who's observing what. I talked about this in an earlier video, but today I want to focus on the consciousness issue. The interpretation from Wigner and von Neumann is weird, but not wrong. Still, it never became widely accepted. I believe the major reason it's never been popular with physicists is that it's unnecessarily complicated. No one knows what consciousness is anyway, and if you want to calculate the outcome of a measurement in quantum mechanics, you don't need to know. So introducing some psychophysical factors to induce the collapse of the wave function is just unnecessary word salad. Philosophers dislike this interpretation for a different reason, namely because it's internally inconsistent. You start with assuming that consciousness is not subject to the same laws of nature as everything else because it's extra-physical, but then consciousness interacts with the physical world, and that means it's itself physical because you can test its effect on our observations. It's the same problem as dualism. If the mind is non-physical, then it doesn't help you explain observations in the physical world. You can't have your cake and eat it too. But there are still people working on it. For example, just a few months ago, David Chalmers and Kevin McQueen wrote a paper about this. They proposed to address the issues of the Wigner-von Neumann interpretation by using a particular mathematical model for consciousness, that is, integrated information theory, IIT for short. We briefly talked about IIT in an earlier video. The basic idea is that each system is assigned a quantity, big psi, that you can calculate from how well connected the system is and how it processes information. The bigger psi, the more conscious the system. In this theory, consciousness is not binary, it's not on or off, it's gradual. This is why Christoph Koch, one of the proponents of integrated information theory, thinks it's a panpsychist theory. Everything is a little bit conscious, it's just that humans are a little bit more conscious than carrots. Though I want to apologize to all carrots who are watching. In their new paper, Chalmers and McQueen use IIT to build a model for wave function collapse that is induced by systems which are sufficiently conscious in this quantifiable sense. This is no longer an interpretation of quantum mechanics but a modification, and it leads to predictions that differ from those of quantum mechanics. For example, they propose that some states that a quantum computer could generate might be sufficiently conscious and thus induce a collapse, though the details depend on the model. For a paper by two philosophers, it isn't bad. My major misgiving about their consciousness-induced collapse model is that it's unnecessarily complicated. If you're building a model in which collapse is induced by a macroscopic thing, why use a brain? Why not use the measurement device? Or cheese? I would like to propose that it's really cheese that collapses the wave function. Prove me wrong. Okay, so here we have people thinking that it's somehow the amount of consciousness in a system that induces collapse, which is kind of weird already. But there are also people who think that deliberately focused attention actually influences how a system collapses. This idea was also brought up by Wigner, though I think it wasn't his intention. In 1967, Wigner published a very influential essay titled Remarks on the Mind-Body Problem, in which he wrote, "We do not know of any phenomenon in which one subject is influenced by another without exerting an influence thereupon. It's not a big step from there to conclude that if conscious knowledge can be influenced by the result of a quantum experiment, then your conscious knowledge can also influence the result of a quantum experiment." Now, add to this that back then scientists were still experimenting with telepathy. Some of them were also studying if concentrating on the outcome of a random number generator would change the outcome. It was just a small step from there to the idea that if you focus your attention on photons going through a double slit, that affects the pattern on the screen. I'm not making this up. This is literally how those experiments work. There have been a few of them since the 1990s. The most recent one was published in 2020. The idea is that when a conscious being concentrates on the light passing through a double slit, then that has a similar effect as if you had measured which slit the light went through, so the interference pattern should change. The authors describe the experiment as follows. It was explained to the participants that they could try to mentally see or image which of the two slits the photons were passing through, to become one with the optical system in a contemplative way, to mentally block one of the two slits, or to mentally bend the laser beam so as to cause it to pass through one slit rather than both. They then statistically analyzed the difference in the interference pattern between the cases where the participants were told to concentrate on the double slit and not. The authors claimed to see a statistically significant difference. Their analysis method was later criticized by another group, which argued that the method of analysis is unreliable and the results can't be trusted. Similar criticisms have been raised about earlier experiments. How difficult can it be, you may ask, to figure out whether the pattern of a double slit changed? Well, the issue is that the common illustration with multiple stripes for the unobserved double slit and two thick bands for the observed one is so misleading I can only call it wrong. It's because a single slit also makes an interference pattern. It just looks slightly different from that of a double slit. So if you don't expect your conscious observations to affect really each photon, it can actually be difficult to tell the difference. There'd be easier examples to look at, but maybe they didn't want that. In any case, the brief summary is that the results of experiments that claim to find an influence of conscious thought on the outcome of quantum experiments have remained highly controversial and have not been reproduced. In addition, the idea that your conscious attention somehow influences what the wave function collapses into doesn't make sense. Wigner was right in saying that in physics, if one thing can affect another, then that influence can go both ways. But that doesn't mean that the influence is equally relevant in both directions. If it rains, you'll get wet. If you swear at the sky in response, then the pressure waves coming out of your mouth move some air molecules, so they indeed influence the rain. But for practical purposes, it doesn't make any difference. And your brain indeed has a physical influence on its environment. That's because thinking generates electric and magnetic fields, but they're too weak to collapse the light going through a double slit. I believe this is where the idea of quantum healing comes from, that by focusing your attention you can somehow influence what processes happen in your own body. My major problem with this isn't even that it's pseudoscience, but that it blames patients for being ill. Hey, if you're dying from cancer, that's your own fault. You should have learned more quantum mechanics when you still could. Finally, let me add a brief comment about Roger Penrose and Stuart Hamaroff, who are maybe most famous for claiming that consciousness has something to do with quantum mechanics. Their argument, however, is a completely different one. It's that the collapse of the wave function leads to consciousness, not that consciousness leads to the collapse. They have this idea that in the human brain there are certain large molecules, the microtubules, that can form coherent quantum states, and their collapse is relevant for consciousness. There are several problems with this. First of all, you wouldn't expect such large molecules to remain in quantum superpositions for a sufficiently long time in the human brain. Second, all cells have microtubules, so how come my liver isn't also conscious? And third, what's this whole microtubule business got to do with consciousness anyway? By the way, in my book Existential Physics, I have an interview with Roger Penrose about this. So, in summary, A. That consciousness causes the collapse of the wave function is a possible interpretation of the mathematics, but it's as problematic as all other interpretations of quantum mechanics. B. One can formulate a collapse model based on this idea, which is a testable modification of quantum mechanics, but in all honesty, I think if they test it, they'll just rule it out. C. The idea that you can influence the collapse of the wave function by thinking is pseudoscience. And D. None of that is what Penrose and Hamaroff are on about, which is another story entirely. Yes, I've been talking about quantum mechanics again, but if you want to really understand how quantum mechanics works, then passively watching videos isn't enough. You have to actively engage with the subject. Our sponsor, Brilliant, can help you with that. Brilliant offers courses on a large variety of subjects in science and mathematics. The great thing about their courses is that they're all interactive with visualizations and follow-up questions, so you can check your understanding right away. This is why I like to look things up on Brilliant. It's fast, it's easy, and it tells me what I need to know. To understand better what I talked about in this video, check out, for example, my course about quantum mechanics. It gives you an introduction to interference, superpositions and entanglement, the uncertainty principle and Bell's theorem. It begins from the very basics, so you don't need to bring any background knowledge. And after that, you can continue maybe with the course on quantum objects or quantum computing or wherever your curiosity drives you. If you're interested in trying Brilliant out, use our link brilliant.org/Sabine and sign up for a free trial where you'll get to try out everything Brilliant has to offer for a whole week. The first 200 subscribers using this link will also get 20% off the annual premium subscription. Thanks for watching. See you next week.